Brought to you by Chemistry.
Hi everyone, and welcome to Brought to you by Chemistry. What's brought to you by chemistry, I hear you ask? Complicated reactions? Complicated exams? Even more complicated romances? Yes, but in this case it's also a podcast series from the Royal Society of Chemistry. So you see the branding there. So you see it, there's branding there. My name is Dr. Alex Lathbridge, and we are back and better than ever. We're fully charged because in this series we are taking a look at batteries, bringing together experts from inside and outside the world of chemistry to help us understand the ins and outs, the positive and negative, the ups and downs of all things batteries. I am, of course, going to ask you a very difficult question to start with. It is, could you please introduce yourself?
Yeah, thank you, Alex. Yeah, my name is Claire Miller. I'm the Director of Tech and Innovation at Octopus Electric Vehicles. And so my role goes across everything in our business, from our digital environments and the websites and the quoting tools our customers use to build their vehicles and order them, through our systems. So everything that our team needs in order to order and deliver cars on a lease to our customers, and also our customers to interact with our brilliant products, all the way across to innovation in mobility and energy. And so I lead on vehicle to grid with our power loop, vehicle to grid trial, and lots of fun overlap between, is your car driven by a battery, or has your battery got wheels? So yeah, that's the kind of cool innovation stuff I get involved with as well.
Car driven by your battery, or does your battery have wheels? That is a philosophical question. All right, I like that. And that actually leads on to my very first question. It's a doozy, okay? What is an electric vehicle? Because I hear it thrown around like a lot. People are like, oh, electric vehicles, electric cars, electric. What actually is an electric vehicle? Like, lay it out for me. What is it?
That's such a good question. Thank you for asking that. No one asked me that. I think there's like an assumption that, like, yeah, of course we all know what that is. So like, electric vehicle, it can be any car that is any vehicle that is driven by a battery as its like propulsion unit. I think electric car is probably what pops into people's mind when you say electric vehicle. So passenger car, you might think about a Tesla, which is pretty famous, pretty ubiquitous, like the one electric vehicle that went mass market. But that can go everything down to like micro mobility. So it could be like an electric vehicle, could be a scooter with a motor, could be a pedal bike with a motor, and could be everything now up to like trucks and HGVs and even more broadly. Like, if we want to really expand our minds, there's electric flight, like human electric flight is coming. So like eVTOL, like electric vehicle takeoff and landing, and maybe even further than that, who knows, like some shipping. There's like some very nice ships and boats and things. So there you go. It's about, how do you propel yourself around the world on this vehicle? And if you're using a battery, it's an electric vehicle.
Okay. So, I mean, I'm really going to expand the full range of how we're going to take this. So you said electric cars, you can have electric cars. I'm just going to do quick fire. All right.
Oh, love it.
Okay. Cars. You can have electric cars, right? Yes,
Yeah.
no. Okay,
Yeah.
Cool. All right. What about bikes?
Yeah.
Okay. What about planes?
Yeah.
Okay. What about helicopters?
Yeah. Helicopter stroke drones.
Stroke. Okay. Well, this is the philosophy. You're really expanding. You're really pushing this. Okay. What about tractors?
Yeah. Although maybe hydrogen's better, like, for that application, but yeah, electric tractors. Yeah.
Okay. All right. Trains.
Yeah.
Okay. What about metro systems, like the tube?
Yeah.
Yeah.
Yeah,
That could be a thing. Okay, all right.
I think also there's a really good question in here, which is about, like, are you charging up like a storage device and then you're using that to move you around, or are you actually like taking the electricity as you are moving the vehicle? So there's a really interesting crossover, which is around like vehicles that use pantographs. Have you come across pantographs? So a pantograph,
obviously, all the time.
You definitely have.
Yeah, I'm currently wearing pantographs. What's that?
Okay, so if you've ever seen a train going along a track and it has like a kind of like massive coat hanger thing touching from the rail up like down to the train. That's called a pantograph. And so there are trials right now with HGVs, lorries, that drive on battery on the road. And then there's parts of the road that are electrified with a pantograph. So literally taking that railway technology and bringing it to sections of the motorway where the lorry can pick up contact to the pantograph, charge its battery a bit as it's going, and then like off it goes again. So because you mentioned about underground, that made me think about that. Like the underground is being driven by the electrified rail. So yeah, it's pretty existential. I'm loving this. This is awesome.
That's actually kind of terrifying a little bit, because you're talking about driving on the motorway. There'll be a bit of the motorway where like an HGV can be charged up. But as someone that drives on the motorway a lot, like if I saw, like when you see trucks in front of you when they're carrying like bits of wood and stuff, and you think of the film Final Destination, you think I have to speed past, or if it's a hydrogen tanker, because like I do not want to be here. I think of it like that. If there's a hanging down electrical thing, isn't that going to affect me? Like, imagine if I had bikes on top of my car, wouldn't they get hit by this pantograph? Obviously I don't exercise really, but like, you know what I mean? This conversation is going in a wildly different direction from where you thought it would be going this morning.
No, it's fascinating. And it's a really good point. So like, so the cables are like really high. The systems have like an auto pickup with a motor, so they can like raise and lower depending on like where the lorry's at to pick up the rail. And then also it has to like make the full circuit. So it's a bit like, why doesn't a pigeon get fried sitting on a massive power line? And it's like, it's not actually making a circuit. It's both its feet are on the same line. So it's not actually making a full circuit. It's a similar kind of concept. But yeah, there are those safety considerations, and it's really important to think about those as we're like innovating, is to think about those real world practicalities.
Can you explain why Octopus, like as an electricity company, are interested in like the electric vehicle market?
Yeah, so Octopus Energy is the electric part, and like the customer electric part of the business, and actually at the heart of that business is technology and also amazing customer service, and that is what actually goes through all of the Octopus like group. All of our group companies is all about like bringing technology to disrupt and deliver really amazing customer experiences. And actually, if you think about electricity is what is going to fuel these vehicles. And actually, electricity is what we need in our homes. It's what we're going to need to heat our homes. We can talk about that. I don't want to like dilute the electric vehicle chat, but like moving away from gas heating, burning gas in our homes. It's one of the biggest contributors to carbon emissions, and we need to have electric heating with air source heat pumps and other like technologies. And when you start to think about it, actually, the electric is at the heart of all these things. And so electric vehicles is one of those places in our lives where, we will be using electric to move ourselves around. Having an electric vehicle business, one, it is to help people transition away from ICE vehicles. We look at the price of fuel right now. I mean, even before the recent kind of fuel crisis and war in Ukraine and lots of lots of these kind of bigger issues in the world, like it was already quite expensive to buy petrol and diesel, and actually it's much cheaper to use electricity to fuel your vehicle. And aside from that, moving away from those polluting vehicles as well is really important. So that's like one of our main missions at Octopus Electric Vehicles. So the crossover with the energy is then, once people have an electric vehicle, it really opens your mind. It's like a gateway drug to thinking about energy, and it's thinking about, hang on, I put the kettle on, that actually uses quite a lot. And actually, all these lights in my house, why have I got them on? Then you start to think about at what times of the day do we have to burn a lot of gas to meet a really high demand around tea time versus overnight. Often when it's windy, absolutely loads of electricity on the grid, but nowhere for it to go. And so what we want to do is to help people understand that, like, yes, your electric vehicle helps you move around the world just like your car does now, but it also does so much more. So it's a place to put energy at a time when there's lots of renewables on the grid, and it gives you that choice in the future to maybe use that energy at a different time of day when it's going to help you financially, and it helps the grid as well. So yeah, electric vehicles there's a lot more to electric vehicles than your petrol or diesel car.
That was a lot. There's a lot there, and I feel as though as someone who's in this world, you perhaps understand it a lot better, which is why we have you here. It's not just for, no one can see this because this is an audio medium, but a fantastic jumper you're wearing. Covered in what? What's it covered in?
Little lightning bolts.
Very, very, very on brand. I appreciate it. So I am interested in an electric car. Like my next car, I would like it to be electric. I've currently got a 2008 Nissan Micra. If anyone's looking to buy one, let me know. And it's difficult. Like you're saying now with fuel prices being so high, but even in the past, like it's not fun being broke and trying to fill up a car. Like, have you ever tried putting your car into neutral and then gliding down a hill, just being 100%. Like, come on, this has got to get me home. This has got to get me home. When I was a student,
100%. That was definitely my life.
And so, like, what would actually happen if everyone, like tomorrow, everyone switched to electric vehicles? Could the national grid, could the country support that?
Oh, it's such a good question. I mean, and like you say, there's a lot to unpack there. I think the two main things there, I think, are around, shifting our mindset to like the time at which you're buying this fuel, inverted commas, like can influence the price. That, like you say, that's not something that we're necessarily used to. And the other one is, can the grid cope? And I'm going to put some like conditions around that, because right now, like, even if we could all switch to electric, we can't get those cars at the moment. It's a really like quite a big restriction on supply of cars. And actually, you mentioned your car. Do you know what? The secondhand car market is crazy at the moment. Cars are appreciating in value. So your car is making money purely because you own it. Because right now, there are not enough cars available for the people that want to buy them. And like, it's a real like, I don't know, it's a real like economics case study. We're living in this like living lab where there's not enough vehicles coming into the market new. That's electric or petrol and diesel, because there's a massive shortage of chips, silicon chips. And you think about anything that uses chips, it's not just the vehicles. So I don't know if, there were friends of mine who were trying to get video games like Xboxes and things like that over Christmas. Couldn't get them, couldn't find them because there weren't enough chips. And actually, that's having a knock-on impact in terms of car manufacturing. So there's not enough new cars making it into the market. And we mentioned Ukraine. It's really starting to impact some of the supply chains now for all cars to get enough parts to the right factories to build the cars. So actually, secondhand cars are going up in price at the minute. Anyway, so back to the questions about the energy cost at different times. I think that's all part of our like transition to this new world of like cleaner, greener energy, and having choice over like when you fuel and when you don't fuel. Because actually at the minute you don't have a choice as a petrol diesel driver about when you fuel, like when your car's empty. You don't have a choice. You have to go somewhere else, and you're stuck with the price that they are giving you, and you have to take it because otherwise your car's not going anywhere. Whereas when you have an electric vehicle, you have a choice of like where you're going to charge. Not everyone has a driveway. If you've got a driveway, then you can access your tariff at home, cheaper overnight than during the day. Or there's lots of like on-street parking and like sharing other people's charges. There's lots of different models there. And then the other question about the grid. Well, look, the national grid, those guys and girls are amazing, and they have got some very grand plans for how much they're going to increase the capacity of the grid. So at the moment, if we snapped our fingers and we plugged in all the cars right now for literally everybody in the whole country, then yeah, it probably wouldn't go down so well on the grid. And actually, on a smaller scale, we see that when everyone gets home from work. That's what we see, right? Or the FA Cup final halftime, everyone puts their kettle on.
I thought we were going to go for the EastEnders effect. Is that not a thing at the end of EastEnders or the start of EastEnders? Everyone puts the kettle on.
I'm going to guess that now we have like streaming services that actually there's not that many events now that like millions of people tune into at the same time. So that's why we're like FA Cup or like World Cup final, maybe like opening ceremony of the Olympics, things that like people would be tuning in at the same time. But yeah, it's exactly that. Like I know exactly what you mean. Everyone gets up, put the kettle on. And so I think it's that effect that we're looking to like help the grid, certainly through vehicle to grid every day, sharing a bit of battery from vehicles to like reduce the peak. But actually, there will need to be an increase in the capacity on the grid. And that's not just for vehicles, that's for heating as well. And actually, we need to do both together. So the grid's going to get bigger, more capacity. But actually, if we can be smart about thinking back to that, is this a battery on wheels? Somewhere to put energy. And when you've got a lot of renewables, so when we stop burning coal and now we're going to stop burning so much gas, we start making a lot more energy from wind and from solar. Sadly, we can't make the wind blow and we can't make the sun shine. And though, unfortunately, when we make energy using those technologies, we need to put it somewhere so then we can use it later when it's not sunny and it's not windy. And electric vehicles are awesome, an awesome place to store that energy to then use it later on. And so, like, vehicle to grid is a really good example of what we're going to be able to do in the future at scale when we've got millions of cars on the road that can do it. But right now, electric cars, just charging them overnight, like in an orchestrated way, in a managed way, is an amazingly powerful way of like storing this energy. And we're already doing that right now. So customers can get onto something called Intelligent Octopus, where we can turn your car kind of to charging on and off overnight so that it's charged up to the amount you want it in the morning, but we've done it in a way that really helps the grid, and you get a really good tariff associated with that. So that's like the first step towards like full vehicle to grid, and we're doing it right now.
With what you've explained there, and I think for me and probably a lot of the listeners, I guess it's that shift in mind from treating your car as being this is just a functional thing. This gets me from point A to point B. I'm filling it with, fuel, using it to go somewhere. Whereas you're sort of thinking about treating cars, electric vehicles, as like a decentralized sort of energy storage, where there's that real give and take. So like we're all small parts of the electricity grid. That makes sense. Okay. Is that's sort of the vibe?
Spot on.
Oh, sweet.
Nailed it.
Oh, fantastic. Okay. So with that in mind, why are electric vehicles so expensive, Claire? Look, you're talking like, oh yeah, it's a great thing to do. Like, why are they so much money? Because I'm looking to get like an electric vehicle, but I go on secondhand, like I try and buy, secondhand electric vehicles. They're still like, 20K. And even then, you'll be on the website and it'll be like, we're not sure if it hasn't previously been used as like a taxi, as an Uber or whatever. It's a year old. Somehow it's clocked 100,000 miles.
Yeah, it's another good point. And actually, it goes back to partly what I said about supply. Actually, it's also about like being a newer technology in the market. So actually, like usually what happens in the the like technological like steps forward is that it takes a lot of money for the manufacturers to like develop and build and test and then launch those products. And so the first products that come out are more expensive because they kind of claw back their investment. And then those like products become a bit more ubiquitous and the prices start to come down because then the next big thing comes out. So like I always remember my mum's car had winders on the windows. You have to like wind your window down and wind it up again. And I remember this amazing day when we got our new car, which was like second or third hand, but it had electric windows. I was like, oh my God, we've completely arrived. Electric windows, amazing. And I think with electric cars, it's that kind of writ large. Actually, a lot of this technology is still really new and the manufacturers have spent a lot of money like developing it. And so they're going to try and claw back some of that. But another challenge to your point about like secondhand cars, what I mentioned earlier, is that right now we are in a bit of a weird bubble that people have not seen before, which is that you've got this very restricted supply on vehicles generally coming into like developed markets. And electric vehicles haven't been around that long. So you also don't have that many that are coming onto the secondhand market. So you've got these two things at the same time. It's like there's not many electric vehicles anyway, and the ones that are coming on secondhand are suddenly making money. They're suddenly like, honestly, if you I had this thing where we were looking at one of our vehicles that we own as a business that we use, and I was looking at the price, and literally over the course of 12 weeks, it was jumping like 1,500, like £3,000. It was literally going up in value because of this weird bubble we're in. So what I would say to people is that like, don't be disheartened. The prices are going to come down, and also there's going to be a lot more choice once the manufacturers resolve these supply chain issues, which, being brutal, like could take another year or so to get those supply chains back up and running. But actually, there's so much demand, there's so much interest that they're bringing cheaper models and more supply, and then we'll start to see cars moving into the second-hand market, third, fourth. And you know what the brilliant news is? is that the batteries that are in these vehicles are incredible. And the manufacturers themselves are starting to come out saying, we can't believe that our batteries are so great. Like, we wanted to be conservative with a small c, and we still can't believe that they're so good as a consumer. Like, how do I know that this secondhand car battery is okay? So the good news there is that the manufacturers themselves are super excited about how their batteries are performing. And there's lots of interesting like innovation coming in assessing the battery. So like taking a health check of that battery at the point at which you might buy it is going to be really important. That's my like one to watch. Yeah, it's my one to watch for the future. When you're buying a secondhand petrol or diesel car, you go for a test drive, you listen to the engine, you might do like the 50-point check with like the oil and the battery with and the brakes and this and that. With an electric car, it'd be really important to like assess the battery. But actually, another bit of good news is that those manufacturers, they had grand plans for like taking those batteries out of those cars and making them into like second life products. So maybe like a battery that's just like bolted into your home that you use to store energy there, or maybe like putting those together and making a grid scale battery. So like literally in a shipping container having 20 or 40 batteries together to make a bigger battery. They can't get the batteries because they're performing too well. So it's kind of an irony that the vehicle batteries are amazing.
I guess they're trying to build that infrastructure to recycle and reuse the batteries, but it's too early on to like really see how we can do that, because we don't have enough batteries that are at the end of their lives, because the batteries that are coming out now are in fact better than they thought it would be. Do you think it'd be possible to create like a full like circular economy, when it comes to like these batteries? Like, you put them in cars, after they're done with cars, you can put them, like you're saying, in shipping containers, or use them to charge one part to power like one part of your home or something. Could that be a thing?
100%. And it's really mind-blowing. And isn't it like, does it make you feel happy? It makes me feel really happy.
Yeah, it makes me feel happy in like a general cool sense. Me as a human, as a scientist, that's a really fascinating thing. Oh wow, that's so cool. Personal sense, Alex, I'm still broke, so nothing at this point has changed. Let me be blunt. I'm still like, this is great. So you're saying that it could be, we could get to a point where batteries are able to sort of, after their use in cars, they'll have this second life. But let's say I have an electric vehicle. Like, are they fundamentally cheaper to run? And like, how long do you actually have to have an electric vehicle for savings to be worth it? Because like for me, when me and my wife, she'll get mad at me if I say me and my wife have looked at we've looked at sort of electric vehicles. One of the ways that we worked out that it might work out is like early adopter advantage, in that like I could go to Lidl, and then while I do my shopping, it's an hour free. Or if I go to the cinema near me, you can get like 45 minutes free, and you can have all these different charging points. Some are fast, some are whatever, some are not as fast. Does it actually work out cheaper? Are there actually savings to be had there?
Yeah, absolutely. So we call this total cost of ownership. So you might hear like people talking about TCO. It's a bit of a buzzword, or a bit of a buzz acronym, right? So basically what this means is, think about how many miles you do. And this is what's really important to this. It's really personal to you as an individual and your family, and what you do with your vehicle. Think about how many miles you drive, maybe a year. And you think about what that will cost you if you put petrol diesel into a petrol diesel car. So you can work out just the running cost alone of like how much that's going to cost you. And right now, obviously, those prices are going up and up. So you need to make some assumptions. We're scientists, engineers, and make some assumptions about what that might look like. You compare that to charging your electric car and how much electricity is needed to take you the same number of miles. You can do a like for like running cost comparison. You mentioned a really interesting thing there about like where you charge and like trying to like pick up free charge and stuff. There are still quite a lot of places where you can get a free charge. And there are lots of places where, at work, they're going to be installing chargers, for example, where you might be able to get a bit of work. And at home, your domestic tariff, Octopus leads the way in time of use tariffs. So tariffs that cost you different amounts at different times, but others will come. And again, there's a whole like side story there about what happened in the energy market in the UK when, unfortunately, lots of energy companies weren't able to continue operating, and a lot of innovation, I think, was sort of lost out of that ecosystem. But it will come and it will come back. So there's lots of different options for charging, which will impact how much it's going to cost individuals. But if we take a big step back, actually, over the course of 3-4 years, it's in massive savings on those sort of running costs, and then you lump in the cost of the vehicle itself, and you're totally right, Alex. Like, it is more expensive upfront to buy a vehicle. We actually support people into leasing vehicles. So actually, the cost of ownership for somebody with Octopus Electric Vehicles is actually over the course of 3, maybe 2, 3, 4 years. Our monthly payments is what you need to be putting in there. So the monthly payment, which kind of gives you access to that vehicle, that could start another conversation about, why would you own a car? You want mobility as a service, like you want to go somewhere, you don't want to own the thing. But anyway, it's part of that for now. You can start to think about, yeah, I know, terrible, but there's so many puns in this space. Yeah, park that for now. The cost of leasing over those few years, plus the cost of running the vehicle, it kind of blows the ICE vehicles out of the water. And then in terms of like places to find cheap charging, like lots of supermarkets actually still have cheap charging. It's slow, so keep that in mind. So like, you're going to do your shop, as you say, you're going to pop around the shop, you might go to cinema, you might be doing something else. There's often like a free vend or a free charger, and I guess that also hopefully starts to get people thinking about like how you charge your vehicle is a lot more like you charge your phone than it is like fueling your ICE vehicle, your petrol diesel vehicle. So your I should also say ICE is internal combustion engine. That's another little acronym in the industry, like petrol and diesel, ICE vehicle. And so, yes, if you can see a charger, like, do a little top up. Why wouldn't you? Especially if it's free.
On that, I mean, this is just sort of a side thing, but like many people my age and younger, the 20s, we're looking to buy property and stuff. And, like if I could buy a flat or a house at some point, that would be sick. One of the first things they say is like, we will look into the fact that if you are leasing a vehicle, that affects, how much money you can borrow. That affects your ability to actually buy a home. So like all of these things are sort of changing and saying, I know, from your perspective, from Octopus, there's Octopus's perspective, there is the idea of leasing, I've seen that, but like, for many people, they would like to buy a car outright. That would be a nice thing to have. So, I mean, you're talking about, this idea of cars being really part of our grid and stuff. Like, if let's say somehow I have an electric vehicle and, I want to be able to sell money back to the grid or, somehow be part of that ecosystem, will that affect my car? Will that make my car battery like worse if there's electricity going back and forth and back and forth?
I think once people get their heads around the idea that you can get the electricity out of the car battery as well as put it back on the grid, because that's pretty mind-bending. Once you think about that, because again, you don't take the petrol out of your car and like put it back in the pump. And I think that is quite a big step for people to be like, why would you do that? Why would you?
That's the thing that gets me, because that's the first thing I think of. It's like, no, once I take it from the place, it's in my car and I own that. That is my fuel. No taking away from me.
That's it. And I think like the point you made there about leasing versus ownership, again, like it's about like a kind of sharing economy, not an ownership economy. And actually, it's a massive cultural shift. Like thinking about, I just need a service that gives me like access to music. Why would I have hundreds of CDs kicking around my house? Like Spotify totally makes sense. We made that shift, but like I remember having a very decent CD collection. I took a lot of time and money to build up. Totally not needed now. Very upsetting, but it's got to let it go, because actually, I want to listen to music. I don't want to own loads of basically bits of plastic. And I think with cars and then with this energy, similarly, I've kind of got to be a bit less precious about like owning it and controlling it and keeping it. And actually, the numbers, to your point around like owning versus leasing, like it doesn't stack up. To invest so much cash in something which immediately is worth less to you, and the risk as well of like running that vehicle goes away when you lease it. But actually, the question you asked me was about energy, and actually, once you get your head around the fact that the energy can come out of the battery as well as in, then you start to say, well, okay, how am I going to use that energy? And that's what I meant about like the gateway to thinking about energy in your home. You think, well, hang on, like I can choose when I use energy now, I've got somewhere to put it for later. And I think that's the bit that's going to blow everybody's mind and be really exciting. So on a practical level, like moving energy in and out of the battery is what the battery is designed to do. Now, for vehicle to grid, we park the vehicle somewhere next to a special charger, and it sits there for a bit, gently discharging. So the energy is moving out of the car according to like a very controlled like exporting profile, which means it comes out like nice and slow, nice and controlled, according to a quite smooth kind of downward curve. If you were to like look at a graph of the energy leaving the battery, if you discharge the car the other way that it can do it, that means you've got to drive it. And so actually thinking about energy comes out of that battery somehow when you use the vehicle. And if you drive the vehicle to get the energy out, how are you driving? And that is another massive topic. So electric vehicle driving, so different to an ICE vehicle. It's much smoother, much more fun. Like it's direct.
I mean, you're not going to say it's bad. Like you're not going to come. It's like a car salesman.
Well, also,
like, nah,
I mean,
it's pretty naff.
Also, if I were to say it was bad, like everyone listening to this who's got an electric car would be like, nah, it's amazing. So like they would call me out straight away. Like, so actually, and the cars themselves are like much nippier and like quicker off the mark. But for the battery, that's not always the best life, right? So town driving, fast, slow, stop, start. But that's what they're designed to do, and that's what they're designed to cope with. And as I mentioned, those batteries are lasting incredibly well under those real life driving conditions. Compare that to being a vehicle to grid, to doing a vehicle to grid session. That's like a spa break for the battery. We're starting to see studies now coming out which actually say that not only does it not harm the battery, actually, if you're doing it in that, so batteries behave according to an S curve. Okay, so they like to live between about like 30% and 80%. You know, that like nice, like I'm doing hand signals that you can't see on a podcast, but like anyone that knows what an S curve is.
The sweet spot.
Yeah, and actually in there, like the battery's like super happy. And there's emerging evidence that by doing this like gentle charging, discharging, cycling for vehicle to grid, you might even be like conditioning the battery. So actually you're extending like the time at which it has quite a high state of health. So the time at which it operates in its like, in its best state.
So, I mean, we've had this super long, super wonderful conversation. Now, would you be able to say, I mean, this is the last question I always ask people, if there was one thing you want listeners to take away from this, what would you want that to be?
The future is really exciting and it's really bright and it's really hopeful. And I know that day to day, particularly right now, it might not feel like that. And actually, being serious for a minute, like the things that you've touched on there around affordability and access to these technologies and, equity or equitable, access to things, that isn't the case right now. But it's getting better, and there are lots of us working really hard to make it fair and to have a fair and just transition in this, transition to clean, green energy and mobility. So it is a hopeful outlook, but it's coming, and it's like keep your eyes and ears open, be curious, bang on the doors, right? So go to your energy supplier and say, like, what are you doing about this? What are you doing for me? When am I going to get access to these better tariffs and these? Like, why are you still like buying, energy from fossil fuels generation? So you can make your voice heard. You do have power as a customer. So it is hopeful and it is coming and it is going to be really amazing. The next 5 to 10 years, it's going to be an absolutely wild ride.
Right, so could you start by telling us basically what your role is and what do you do at the National Grid?
Yeah, so my name is James Kelloway. I'm the Energy Intelligence Manager at National Grid ESO. So what National Grid ESO do is we're kind of like the residual balancers for the system. So we make sure that the right amount of energy ends up with the right people, and the right amount, and the amount that's actually generated matches what the demand is at any given point. We do that 24/7. So our control centre here is primarily responsible for ensuring security of supply of electricity for the country.
Okay, so is it your guys' job to worry about when it's halftime the football match and everyone puts the kettles on and there's a lot of strain on the grid?
So that's our control centre. So they actually monitor that 24/7. We're more on the sort of the innovation side, which effectively leads into a pipeline. So everything we do here goes into that room as a focal point. So they have the best decision-making, information they can get. And one of the things that I love about working on the grid at the moment is it's ever-changing. It's ever-evolving. I mean, to a certain extent, it's always done this, but we've seen an explosion of wind and solar in recent years. So give you some idea, we've got somewhere around about 23 gigawatts of wind on the system at the moment. We've got about 13-ish gigawatts of solar on the system at the moment. That's beautiful in terms of getting to the point where we can operate the grid with much less carbon. But it also presents us a really interesting challenge, which is they're kind of weather dependent. And, for those of the listeners that aren't in the UK, potentially, the UK's weather isn't the most stable system in the world. It's, clouds going across can affect solar panels. The wind is obviously highly variable. So it's kind of, okay, how do you integrate that with the existing technologies? So just to give you a very brief example of how it's changed, if I go back a couple of decades, actually the grid was designed to work with a very small number of large generators radiating power outputs effectively. Now we're seeing a much larger number of small generators, and that energy can sort of flow in many directions. So the really good thing about the way the grid's set up is it can cope with that, and we can use it that way. It's a really good sort of living setup, if you like.
So how do batteries come into play in how you manage that energy volatility in the grid?
If I look at a typical home setup with a solar panel and a battery, okay? So I look at the one that I have on my house, for example. I've got a 6.2 kilowatt hour peak solar array on the roof. Now, if I just look at what that does, actually, it's pretty effective. But it does vary a lot. So if you've got a really dark cloud go over, the output of the array can be maybe a kilowatt. If that cloud passes away and you get a blue sky, even this time of year, that could easily jump to 4 or 5 kilowatts. Yeah, so that volatility changes quite a lot, and that's not something that you can control as an engineer, because obviously it's fully cloud dependent. So this is where the battery really comes into its own, because what we want to do is to be able to have a controllable output from that generation source, right? So in my home, I've got a very simple lithium iron phosphate battery, which is about 8.2 kilowatt hours. And that will effectively take all of that solar energy, it trickle charges it in. It's not super high, super low, super coming out, So maximum charge in, charge out is about 2,700 watts, about somewhere around there. So about the same as boarding an average kettle. But what that allows us to do is to actually then regulate that quickly changing solar to something that's much more manageable. Now, it then comes down to, okay, how do you apply that at grid scale, and also what do you use the batteries for? Yeah. So there are lots of different ways that you can use batteries in the home environment. Typically it's around about keeping your costs down. Certainly with the energy rises that we've all seen now. So it's maximizing off-peak versus on-peak charging times, or even more agile type pricing structures. So where you have lots of green and cheap renewables running, actually let's store that energy from that period and use it in a period when, let's say, it's dark and not so windy. Yeah. So, but at it's kind of a smaller level. It's then a case of, well, okay, what do you do with those batteries on the grid itself? Which I guess maybe the next step to look at.
That's fantastic. I wanted to ask you about electric vehicles, because obviously there's a big push towards more people owning electric vehicles now.
Yep.
And I've seen like the motorway services, you've got them all lined up. They're all charging at the same time. And so I'm wondering, as we move towards more people having electric vehicles, what impact is that going to have on the grid? And is that something that you're preparing for? Absolutely.
So, let's just take that one at a time. So several really interesting points in there. So I must confess, I'm on my 4th EV at the moment. I became an EV driver long before it was sensible probably to do so. Now there's really no reason not to do it. It's pretty much cheaper when you look at the running costs of the car, and it's much better for the planet. Let's just have a think about how you actually charge an electric car. So if I take my car to a motorway service station, you're quite right. There are lots and lots of charge points out there now. I plug in, and then that takes a draw. Now my Teslas are pretty good. It will take an input of around about 150 kilowatts plus ish, somewhere around there, when the battery's in the optimum condition, i.e. it has to be at about the right temperature with the right state of charge for it to take that amount. Yeah. Imagine you've got 20 of those running at once. That's interesting, right? In terms of the power supply. So those rapid chargers, if you like, they can be powered in a couple of ways. One of which is to directly connect them to the transmission network. So where those motorway service stations are near high voltage systems. So if you think the high voltage is like the motorway network, low voltage is like your A roads, that kind of thing. Where they're near there, connect them in there. They can just pull the power direct. It's not a problem, because in terms of the scale of the actual amount of power that runs the country, it's quite small. Okay, so that's cool. Where it gets really interesting is where you don't have that connectivity, but you still need the charge point. Right? I always think of it a little bit like a traditional toilet, which I know is a bit of a strange analogy, right? So if you think a local battery at that site would operate like your cistern, yeah, and your flush would operate like your rapid charge, yeah, you would trickle the energy in, fill up your cistern, and when your vehicle comes along, you quick discharge, yeah. So you'd have an on-site battery delivering to your car battery. First saw this out in Germany, I think. It's quite a cool way of using batteries. Yes, there's a little bit of loss of energy between the battery to battery transfer, but actually it enables the thing to work really well. It's also worth having a think about the automotive batteries. I mean, my first EV, it did about 140 miles. And that was considered very high at the time when I got it. I've got a small battery Tesla at the moment that can easily chuck out 220, 230 mile range without me really thinking about it in winter. I was reading that actually they've just done a prototype battery test in the US, which is using a Gemini battery in a Tesla Model S, which is effectively a lithium iron phosphate battery, which is the same as I have at home. And they actually put that into a Tesla S. Prototype car. So it's a stock car, but they took out the P100 battery from the Tesla. They put this Gemini battery in, and that actually achieved a range of 752 miles on a real world road trip in winter. That's phenomenal, right? It's probably not going to be commercialized until maybe 2026-ish, but that's the way the battery tech's going. As we start to go towards the solid state batteries, which is incredible, because for those of you that haven't come across this, the solid state allows you to not have the liquid in the battery, and it's the liquid really that determines the life and the sort of, to a certain extent, the safety of the battery as well. So you see this stuff coming and changing very rapidly. Where it becomes also very interesting is when you start to think about bus hubs, something like that. So if I look at the bus the one that we use here at National Grid House, for example. The one that's Faraday House, National Grid House up in Warwickshire, we have a bus that runs between the office and the station. Now that's a fully electric bus. It's not a hydrogen bus. It's not a diesel bus. It's not a hybrid. It's just a fully electric bus, and that runs all day. It just drives in circles around Warwick all day, and at night it comes back. It plugs into its 150 kilowatt charger in the depot. It recharges itself, and off it goes. Yeah, it is. And I love it, because we're kind of like practicing what we preach, kind of thing. Where it becomes really interesting. Okay, you've got a fleet of 100 buses. Yeah, how do you charge them? Because a bus really doesn't make money when it's parked. So you want to minimize that parking time. How does that work with much more heavy scale transport? And this is where your storage element comes in. Do you do that with battery? For some journeys, yes, absolutely. So the example where I'm doing my trip, or if I've got a light goods vehicle, something like that, absolutely go full electric. It'll make sense to. Where you have long, heavy haulage, which doesn't really stop, actually, it might be worth using green hydrogen. Green hydrogen being stuff that's actually made from renewables and doesn't have the impact that blue hydrogen does on the planet. Using that within the vehicle as well to maybe supplement a battery.
Thank you so much.
Hey, no worries, Lizzie. I hope you enjoyed that.
I really enjoyed that. I learned loads. Thank you. I've always wanted to talk solar for the National Grid. I find it really interesting.
My name is Volker Presser. I'm professor for energy materials in Saarbrücken. I have 3 affiliations. One is with the Leibniz Institute for New Materials, the second one with Saarland University, and the third one with SARIN, Saarland Center for Energy Materials and Sustainability, where we try to make the world a better place.
Thank you. And can you just start by telling us what your work is at the moment? And especially, I know you're working on something to do with mining batteries for precious elements. I'm really interested to hear more about that.
Absolutely. So, the name of our team is Energy Materials. So this really means we're looking into not just building better batteries, but also to really unlock otherwise sometimes hidden potential of electrochemical processes, and more the sustainability thereof as well. So we are looking into greener ways of making batteries. We are trying to use battery technology to make water clean. But when you engage in this thought that by applying electric potential, you're not just storing charge, because that is not what batteries do. Batteries store ions. And if you understand that by pushing a button and applying electricity, that luckily you get back after the charging process, you can play with ion management. So this is where in the last years, we really went into what some people call ion pumping or desalination batteries, where we use energy materials to harvest ions from seawater or other aqueous media.
Okay, and what would we use those ions for that we're harvesting?
Well, the question is always, when you do ion harvesting or ion separation, what's the end purpose? One, of course, is making drinking water. So you basically don't care too much about what's inside. You just need a certain threshold of ions to, be under it to make water safe for potable reasons, right? But the same thing applies when you look into contaminants, because sometimes you want to get the bad guys or bad gals out of the system. We're talking about lead, we're talking about other pollutants like ammonia or phosphate. Or sometimes you can swap it around and say, well, it's not the bad people that we want out in terms of ions, but we want the good ones. And there you are interested, of course, these days above anything about lithium. And lithium as the white gold, so to speak, is definitely a precious resource to be tapped into.
Thank you. So can you talk to us a little bit more about lithium and why it's so important to preserve it, and also what are we doing, I guess, to reduce our reliance on mining new sources of lithium?
Lithium is a tricky element. First of all, we are actually at the moment quite hooked on it by present-day lithium-ion battery technology, which is a topic of its own. Will it always be that way or not? But that's the core of electrification, of transportation, and mobile computing at the moment. So there's undeniable a transition. Actually, the share of using lithium for energy is the largest use globally at the moment for lithium. It used to be different applications, but now really has taken over. But lithium is an elusive element. At the moment, we mine lithium by conventional mining technologies, terrestrial mostly. And by doing so, we are reliant on the presence of lithium ore, which is not homogeneously distributed across the globe. So you have certain areas like in South America, you also have in Europe a few clusters like in Portugal, but you don't have a lot and not in many places. And that really brings up absurdities that you mine lithium on one continent, like in South Africa, you ship it across the globe to Asia to be refined into the ore specifically, into then high-grade lithium, then batteries are being built out of it, and then shipped back to charming Europe for our users and customers to be used. In terms of CO2 footprint, not very attractive at all.
So are there ways of recycling lithium that's being used in batteries? Is that something that we're looking at?
Absolutely. So battery companies and electric companies, they are not doing this because they love the environment so much necessarily, but there are very hard mandates of many governments across the globe, including the UK and European Union, that actually mandate a high percentage of recycling. We're looking into 60, 70, 80% and upwards in the coming decades. And to meet that, they are fairly easy to recycle components in batteries. When we talk about lithium-ion batteries, lithium, yes, it's inside lithium-ion batteries, but we have a large amount of graphite. We have a large amount of metal from the current collectors like copper. And a lot of those elements are easy to recover, like especially the metals from the casing, steel that you use high grade there. And there are things that are not so easy to recover, like the electrolyte that you used, or in this case, lithium. So lithium recycling that, you go into shredding batteries, old ones, applying chemical and very often pure metallurgical processes to get back at those elements. Lithium is the one that is challenging to get, but it's definitely something that is driven largely also by costs. Because if you can start recycling those systems, those lithium-ion battery technologies, and capitalizing on the lithium as an ore, not from the earth, but from a spent battery, then we're looking towards not only doing the nature and environment a favor, but also being much more cost effective in the long term and sustainable.
So this episode of our podcast is about electric vehicles. So I just wanted to ask you about, so my understanding is that a lot of electric vehicles today use lithium-ion batteries. So do you see that becoming a problem as we're moving towards a future where hopefully we'll be using a lot more electric vehicles? And I imagine that's going to put quite a big strain on resources. So do you see that as an issue? And what do you think we need to be doing about it?
Excellent question. And, I could start with citing some numbers that are a little bit arguable, like 5% of lithium-ion batteries are only recycled, including the cars. But, are we talking about recycling or reuse? Because you see a lot of second life applications where either the car is being still used as a car with a reduced range, or where you use a battery from a car as a stationary unit for, large scale or medium scale applications. So transitioning from the mobile application to an immobile application completely. So we're seeing a large number of electric cars being produced. It's an immense amount of cars that in a couple of years will require to be thought of what to do with them for continuity of this launching of a new technology into the market and coming back to the recycling plants. So it's not just an environmental concern. Again, it's really the need to transition to circularity, to use this precious resource that we have in those car batteries to make car batteries again or use lithium for something else.
So your work in desalination and extracting ions from water and so on, is that one of the applications that you could use old car batteries for?
Absolutely. So the two tiers that we're currently working at is to extract lithium for natural occurring resources, which can be seawater from the charming coast of Great Britain. It can be also, of course, the mine water that flows here in the rural area of Saarland. But it can also be the wastewater from a battery company factory, or it can be the products from battery recycling processes directly. So we are working on these topics right now in the laboratory, and specifically electrochemical measures have the attraction that they don't use and consume a lot of chemicals and not much energy. So when you recycle, you really need to think about, how to do this also in a, cost prohibitive way, of course, would be a dumb way of doing it. So you should do it by saving kilowatt hours of energy and resources so that recycling actually is green and not adds to the CO2 footprint in too much a negative way.
So did I understand that right, that some of the manufacturing methods and the recycling methods or batteries create pollution and that you can then use batteries to address that pollution? Did I get that right?
Yes, and that's one of the most wonderful closed circles of my career so far, because materials like lithium iron phosphate, which is an up-and-coming electrode material for many applications, it has some drawbacks, but you see a lot of cobalt-free technologies emerging on the market now. And these materials, they are wonderful for storing lithium. And it just turns out they just like lithium. So if you offer lithium iron phosphate, sodium or other ions, lithium is picked out. It's like having mixed nuts and you just pick the cashews that, of course, we all know are the clearly superior nuts. So this material really has a strong affinity towards lithium. And if you offer them, for example, natural occurring water or basically the hydrometallurgical residue of processed black mass from a battery recycling facility, then you extract lithium selectively. And we know the better you can separate the ions, the more precious and the more pure the final products will be, and the easier the following recycling steps will be also.
That was perfect. Thank you.
Perfect.
That's all for this episode of Brought to You by Chemistry. Join us next time where we'll be finding out what can happen when batteries go wrong, and why you shouldn't really take electric scooters on the London Underground. It was produced by Hiran Joshi and Elizabeth Ratcliffe and presented by me, Alex Lathbridge.